Right. In OSPF, there is one small tuning work we need to do today. What is it? Why we need to do? OSPF is quite an old protocol. When OSPF was developed, 100 megabits per second links were not common. According to the engineers on those days, developers on those days, reaching 100 Mbps, it's like an unreachable destination. Meaning, they they did not know that technology will grow faster and we will reach 1 gig, 10 gig, 40 gig links. On those days, it was like in kbps, 56 kbps. Now, that is what the speed of the internet on those days. If you go back to 2003 and recall what we were having in 2003, 4, we were having just dialer, BSNL dialer, which will give you a maximum speed of 56K. So a router transferring data in 100 Mbps was not achieved on those days. So when OSPF was developed, they thought that 100 megabits per second will be a very big speed which cannot be achieved. So let us keep 100 meg as the upper limit to measure the bandwidth. See, what do I mean by upper limit? As a metric to measure. See, if someone wants to measure how tall is the tree, they will compare to some building or something like that. In this building, it will be half the size. So the upper limit is the building size. So they will say those trees in Kerala are bigger than this building. They will say it's bigger than this building, which means they use that building as the reference. Correct. Reference is the right word. So to calculate the bandwidth on this link, they need a reference link, reference bandwidth. So they kept 100 as the reference, thinking that 100 will be the biggest, which people may not reach. Technology may not reach. So they keep 100 as the reference and say how big is their current bandwidth. For example, if I have 10 meg wire, Ethernet wire, which is 10 meg. Now then, how do they calculate the cost? They calculate the cost by saying 100 divided by 10. This 100 is the upper limit, the reference they keep. So the cost is going to be 10. And now if I have another link of what to say, 5 meg, cost is going to be 20. You see, we use that 100 as a reference bandwidth, and now we come up with the cost. This has got the lower cost, so this is the elected best route. elected best route. Without this reference bandwidth, we would have not derived this. Fine. Now, what if we have 100 meg wire, 100 meg wire? What will be the cost? Cost is going to be 100, which is the reference bandwidth, divided by the bandwidth on the link, which is also 100. So cost is 1. Cost is 1 here, cost is 1 here. So to reach the destination 1.1.1.1, the cost is same on both the path AF0, fast Ethernet 0 and fast Ethernet 1. Equal cost load balancing will happen. You don't need to do any extra configuration for equal cost load balancing. When the cost is same on multiple paths, by default up to 4 paths will be used for load sharing. Equal cost multiple. Up to 4 paths. You can increase that depending on the iOS version. It will vary. Some will allow you to have six equal cost path for load sharing. Some will allow 8, some will allow even 32. It depends on the version. Nexus, they support up to 32. You can use 32 paths if they are taking to same destination. Anyway, coming back to this story here, what if I have a gig Ethernet? Instead of fast Ethernet, I have gig Ethernet. 1 gig is 1000 meg. Now the cost here is 1. 100 by 100 is 1. And now for gig Ethernet, 100 by 1000 will come in a fraction number. But there is no metric in fraction. So it will seal it to 1 only. So cost on gig Ethernet and fast Ethernet is same. Will you accept this? Gig Ethernet can carry more amount of data, 10 times more amount of data. But OSPF says, for me, both are same. So if you are sending 500 packets, send 250 on fast Ethernet, 250 on gig Ethernet. Which is not fair, isn't it? Jenna, you are in mute. So we won't be happy. No, it is not fair. This can carry 10 times more data, but we are not sending according to the capacity. Why? Because OSPF cannot differentiate. The reason is the upper limit. The reference that we use is 100 meg. According to OSPF, 100 meg is the maximum, is the reference bandwidth, because it's an old protocol, you see, OSPF. What we need to do is, whenever you have gig Ethernet or something bigger than fast Ethernet, then you have to use this command, auto cost reference bandwidth, to change this numerator value. Now, if I say auto cost reference bandwidth 10,000, When I say 10,000 instead of 100, if I say 10,000, then the cost will become 100 for this. The cost will become 100 for this. And here the cost will become 10. So now OSPF has got better visibility down to the bandwidth. Now OSPF says, yeah, this is the best path. This will be there in the database for a backup purpose. In the routing table, it will put only this path. And because the cost is only 10. You see, changing the reference bandwidth is mandate whenever you are having links faster than 100 meg. But if you are going to set the cost manually, you no need to do this. So this is auto cost. Usually people rely on the auto cost. In OSPF, cost is calculated based on the bandwidth. That is what called as auto cost. Automatically, cost is calculated. But you know, we can go and configure cost manually. If you will do that, then you no need to worry about this. If you are going to go to every link and set the cost manually, simple, you go to the interface and say IP OSPF cost and give a number. If you do that, this formula will not be in use because you have given manually the cost. There is no need for auto cost. But most of the time, people rely on auto cost. For them, this is the important topic. The reference bandwidth you should increase because today in technology we have 1 gig, 10 gig links very easily found in the topologies. Even 100 gig link you can see in data center. 40 gig link you can see in data center. 10 gig link is also seen in data center. So if you go to a data center, you must configure this reference bandwidth. Because in data center, the links are always 1 gig and above only. Very rare to see this 100 meg wire. Is that clear? Shall we go to the next topic? Mhm. I'm sorry? Um, see, EIGRP, because it's proprietary, they upgrade. But OSPF, the open standard, RFC people, they don't do this thing. IEEE, RFC, they don't do this one. I don't know why. This question you asked. In iOS XR, in iOS XE, it's 100 only. You have to change the reference bandwidth. But good news is in Nexus, the reference is 40. So now, only if you are having 100 gig in Nexus, then you need to change. Otherwise, you don't need. See, we have 1 gig, we have 2 gig, we have 40 gig, we have 10 gig. We also have 100 gig. Whenever you have more than 40, then you may need to go and increase the reference bandwidth. Do we need to do it on ASR device? No. Sorry, we have to because it is only 100 meg Nexus. Oh yes, we have to change the reference bandwidth. It's a good. Nexus operating system. Yeah, yeah, yeah. All run only one operating system, NXOS. Whether it is 3K or 5K, 7K, 9K, they all runs Nexus OS, NX OS. Even MDS switches, multi-directory switches, all new MDS switches run NXOS. Earlier, there was one OS called SAN OS. Now they have replaced it with NXOS. So no need to do the reference bandwidth change if we are working on Nexus. Okay, let us go back. All right, so this is very important one. We have learned it very well. Summarization reduces the amount of advertisement that we will send. By default, no summarization done in OSPF. You see, the routes are coming from one area to another area as type 3 LSA. The routes are coming from one autonomous system to this autonomous system as type 5 LSA. There are two different type of LSAs. There are two different type of advertisement that brings update from one place to another place. From one area to another area, it is type 3. From one autonomous system to another autonomous system, it is type 5. Now, those advertisements will be huge, many in number if you don't do summarization. If it is huge and many in number, then the CPU utilization, bandwidth utilization, all will be more. The impact will be in the performance. So the performance will be going down and down when CPU and bandwidth utilization goes up and up. So when you reduce the amount of advertisements, you improve the efficiency of your network by freeing the space in the bandwidth as well as in the processor. That is why we need summarization. OSPF route summarization. As I said, type 5 LSA and type 3 LSA, we need to summarize. Type 3 LSA comes from one area going to area 0. Type 5 LSA coming from an ASBR. So you need to understand there are two different advertisements. So the configuration command will also be different. See, type 3 LSA, if you summarize, we call it as ABR summarization. Type 5 LSA you summarize, then we call it as ASBR summarization. Type 3, if you reduce the LSA type 3 flooding, we call ABR summarization. To do type 5 LSA reducing, you need to do ASBR summarization because type 5 comes from ASBR. Type 3 comes from ABR. We know these things. Fine. Before we see the command to do type 3 LSA and type 5 LSA, let's learn how to use the mask to do summarization. If you notice here, the number begins is 8. and you want to summarize up to 15. So how many numbers are there? 8 to 15, how many? Hello. 8 to 15, how many subnets are there? Are you sure? Are you sure? 9? 1, 2, 3, 4, 5, 6, 7, 8. In that, you already begin with 8. So next to 7, you want to shrink it. So 255 minus 7 is what? 248. 255 is the maximum, no, in a subnet. Minus 7, 248. If you type like this, then it means the subnets. Same way here, you see, 255 minus 3, because the 16 is already here. 17, 18, 19 is what you want to include. Did you understand this part? This is the confusing part for many people, but this is not that confusing. Are you comfortable? All right. Now, we need to know the command. You see, if you are doing type 3 LSA summarization, which is done on ABR, so you can call also as ABR summarization, the command should be like this: area 1 range. So you are taking area 1 command subnets. These are all area 1 subnets. And you're giving the summarized route to area 0. So don't focus on area 0. You need to focus on area 1 because these networks belong to area 1. That's all. This is what called as ABR summarization. But ASBR summarization cannot be done like that. Why? ASBR, if you notice here, there is no area. Earlier, here we had area 1, this was area 0 in the other scenario. But do we have any area now? No area. So you cannot use the command area 1 summary command, area 1 range command. So in ASBR, the networks that you are going to summarize are not from any area. So you cannot use that same old command which we were using here. You cannot use this type of command. This is coming from area 1. 32 to 60, 63, which is 32. So 255 minus 32 is 224. So you use the command area 1 range because there is area. But do we have any area? Do we have any area mentioned here? No. It is some other protocol like RIP. So the command cannot be the same area ID range command. The command is like this: summary address. You need to go under OSPF and say summary address. Network starting from 32 to next 32 network. Next 32, which is 255 minus 32. 255 minus 32. Not 32 or 31. Why I'm playing to 24? Anyway, we'll see. 5, 3, 223. Okay, there is no 223 actually. The block size is 224. All right, so 31 because we are starting from, okay, ignore 32 because we already mentioned that. So you need to count from 33 onwards. 33 to 63 is 31. Include 33. 33 to 63 is 31 number. So 31. 255 minus 31 is 224. See, the command is summary address. For ABR summarization, the command is summary address, whereas for ASBR summarization, the command is summary address, whereas ABR summarization, the command is area ID, range. Now, there is something called default route injection, which will inject the default route. All right, this summarization is over. Do you have any question? Okay, and if you want to, yes. You see, OSPF can inject a default route. The ISPs or the hope in order to take us to remote networks. But how many remote networks you have? Millions of remote networks. So ISP will not give you the millions of remote network routes to you, but they will have it. ISPs will have those millions of routes in a summarized form in their routing table. All that we need to do is, for the remote network, you need to simply forward the traffic, hoping that ISP will take care. That's all our job. How will you tell every router that is inside running OSPF that we have a hope? How do you tell that, hey routers, if you want to go to someone whom you don't know, come to me. You need to tell. Who need to tell? Router 1 need to say that. Router 1 needs to say every other router inside the autonomous system, 10.1.1.1, or whatever. Actually, this is the router ID of this router. Router 1 needs to inform every router in the autonomous system. There may be 5 areas, area 1, area 2, area 3, area 0. It needs to inform, R1 needs to inform everyone that I will take care. Come to me. And router 1 will have a default route or something statically written to push it to internet. So now R1 is the one which is connecting to the internet, which needs to take responsibility to guarantee the packet forwarding to the remote networks. For that, what R1 can do is it can inject, it can push, it can send a default route as LSA type 5. Default route injection into OSPF as an LSA type 5 can be done by typing the simple single line of command under router OSPF on R1. So go to R1 and say router OSPF, and then we say default information originate, and you will see All the routers inside your organization that runs OSPF will have a default route. But provided you need to have a static default route towards ISP. Please pay attention, very important. If you have a static default route towards ISP, then this command default information originate will dynamically send the default route information to every router. What if I don't have static default route to ISP? Then you need to include a keyword called always. The always keyword will allow the default route to be advertised even when the default route doesn't exist. This always keyword is not needed if default route exists in this R1 towards ISP. All right. So you need to know when to use always. Always is needed only when you don't have a default route in the routing table. You see here, you have two ISPs in your organization, and you want ISP on the top, ISP A, to be the primary ISP. So what you do is you use the command default information originate along with the metric. So this is going to inject default route with cost of 10, and this is going to inject the default route with the cost of 100. So this router, what it will do, it will compare and it will say, I'll use this ISP. Only if something goes wrong with this router or the link, this will stop coming and it will switch the packet to the ISP. This will happen automatically. So in short, what I'm trying to say is, you can use default information originate with a metric command whenever you have more than one exit, more than one ISP, more than one gateway. Is this clear? When I configure an area as a stub area, what happens is type 4 and 5 LSA are denied entering. See, does not accept external LSA. What is external? Type 4 and 5 are external, coming from some other routing protocol, some other source, some other autonomous system. Then how will you ping external? Instead of type 4 and 5, this will inject a default route as type 3. There will be a type 3 default route injected given by the ABR to all the routers. So using that, the stub areas can ping external. When you configure it as totally stub area, not only type 4 and 5 denied, along with that, type 3 is also not allowed, denied. Type 3 brings the other area network, right? So now this will inject again a type 3 default route, which will be used to ping inter area as well as external. What is the advantage? Advantage is your routing table is smaller. Advertisements that is coming inside is less. As a result, efficiency of the network goes higher. Did you understand stub and totally stub? You did not get it. Okay. Where you did not understand? What? Stub. Stub. Uh-huh. No. I don't design. You just configure all the routers to be a stub router. Automatically, ABR will stop sending type 4 and 5 inside that stub area. Instead of sending type 4 and 5, it will send type 3 default route. Who will send? Router will send type 3 default route. ABR. So I have an arrow mark written. See, look at this. Is this arrow mark going from here? Tell me, which router it is starting going from? That router only. You see arrow mark going from here? That router only. Why you ask which router when you have the lines drawn? I say this router which is already blocking 4 and 5 will dynamically generate a default route of type 3 and inject it to all the routers inside. And next, where is the understanding issue? Which part you didn't understand? Inside stub area? Are you talking about inside stub area or a backbone area? Okay, or those two routers will get a default route dynamically generated by ABR and given to this two router. You no need to do any default information originate command, or you no need to write any default route. They are dynamically generated by ABR, given to every single router in the stub area. That is totally stub area. When you say totally, which means anything coming from outside. That is why it is total. What all comes from outside? 4, 5, 3. These are the three LSAs usually come from outside. Now, when you say totally stub, you don't want 3 also to come in. So 453 is denied, 345 is denied. As usual, ABR is going to generate a default route as type 3 LSA and give it to inside routers. So using the default route, the inside routers can now reach other area as well as external. Did you understand now? But no, wait, little bit, but okay, will be solved. Wait, will be solved. Will be solved if you go through a lab video which I have already posted in our channel. This is not regular class. This is interview preparation class. So we will not have lab here, but you already have our videos in our channel. Go through the video, stub video, OSPF stub video. And because you did not come for LSA class yesterday, you may face some issue in understanding type 3, type 4, type 5. So now